Okay, let's give you guys some more practice. So imagine you've got some hot water flowing through a metal pipe. So this red thing here is your water flowing through the metal pipe. So so the temperature here is at 90 degrees, and then as you move out here, the temperature is at 23 degrees Celsius. From the center to here, it is 5 centimeters, and from the center to here, it will be 15 centimeters. Okay, and the height here is 20 centimeters, and the height here is also 20 centimeters. So what that means is, at this point here, it is 90 degrees Celsius, and then as you move out here, this here will be 23 degrees Celsius, and the same goes here. Here it is 23. Here it is 90, and then as you move out here, it is 23 degrees Celsius, and so on. So find the average temperature of the metal pipe, not the water. Don't care about the water. Just want to know the average temperature of the metal pipe. Okay, so you can imagine this as being like this, a series of temperature blocks, if you like. So this here is 90, 90, 90, 90, 90, 90, and so on. And then as you move out, it gets cooler and cooler. So let's say 85, 85, 85, 85, and so on. This is 80, 80, and then as you move out, it gets cooler and cooler. Well, anyway, find the average temperature of the metal pipe. Okay, so press pause and have a go. Okay, so to do this here, we really want to sum up the cylinders. We can't really use discs. We can't really use discs because if you think about it, if you use discs, then here the temperature is changing all the time. But if you sum it up by using cylinders, then this here is 90, 90. All the temperature here, they're all the same. So as you revolve it around 360, sum up all the cylinders. The good thing is that all the temperatures here are the same. Okay, they're all the same. So we should sum up all the cylinders. Don't use a disk method here. Okay, well, let's use a cylinder method. So now it's really us summing up all the cylinders. So the average temperature is given by this. So the average temperature is given by, well, we need to take care of this later on. This is our temperature, but we do need to sum up all the cylinders. So we are summing up all the cylinders here. So here, if you look at this one particular cylinder here, the thickness associated with this cylinder is your dx, because you're moving in the x direction. So the thickness here is dx. So that's this dx here, and then we've got to times it with the circumference. Well, we've got to times it with the circumference. So that will then be this, and then we've got to times it with the height. Okay, so this here will give us the cylinder, the volume of the cylinder. So now we need to take care of the temperature. So now taking care of the temperature, remember the temperature is moving in the x direction here. So as you move along in the x direction, the temperature will get cooler and cooler. So we need to model that. Hang on. So the temperature. So remember, we're summing up all the cylinders. So we are moving in the x direction. So we want to set up in such a way that, well, so you've got to imagine that this here, you've got to imagine that this is your x-axis, and this here is your y-axis. So here the x here is 0, x here is 0. So as you're moving along here, by the time x gets to 5, we want the temperature to be at 90. So hang on. So we're moving along here, starting at the center. By the time it gets to 5, which is right here, we want the temperature to be 90. And then as we're moving out here, by the time the radius gets to 15, which is here, we want the temperature here to be 23. So by the time it gets to 15, we want the temperature here to be 23. Okay, so our temperature should be the equation of this straight line here. Well, the equation of this straight line here is given by by this. Okay, so now we've got our temperature now. So going back to the original equation, now that we've got the temperature, we can just evaluate the whole thing now. So we can now put this, hang on, we can now put this temperature thing into here. Okay, into here. Okay, so we will do that later, but let's just factor out the. Remember, we're integrating it with respect to x. So this here is a constant. This here is a constant. So take the take them out. Same with down here, and then that will then take you to here, and then this will cancel out, and then don't forget we're putting that temperature into here now. So that will then give us this. Okay, so this is what we worked out earlier to be our temperature. Okay, so now multiply this out. So that will then give you this, and then now it's just really blah blah blah, and then that will give you the average temperature of roughly 51 degrees Celsius. So going back to our original diagram. So the average temperature here, the average temperature is roughly 51 degrees Celsius, I think. Okay,